Hello. Bună ziua Iași. Foarte frumos să fie la Iași din nou. Today, I'm going to talk about architecture, continuous architecture. Might not be a huge surprise to those of you who know me, but how many people here, I can just about see hands, are called an architect at work? A few, but how many of you do architecture work? A few more hands, exactly. So let me see if in 45 minutes I can persuade you all that architecture is everyone's business, because that's the point. My name is Eoin Woods. I realise if you're not from Ireland, that's not very obvious. Leave the E off the front, pronounce the rest of my first name. That's pretty close. I work for Endava. Never duplicate data. I just see I've updated my job title in one place and not the other. I'm Endava's chief engineer. Many of you will know Endava. We've been in Iași for many years, and some of you I know have worked for Endava. I'm specialised as a software architect. I've always done software development. Why are we talking about how we do architecture? Well, the main reason is that over the years, how we do software development has changed. You may notice I have grey hair. I've been doing this a long time. When I started off, when we built systems, we started with Unix, which, believe it or not, was innovative at the time, a C compiler, and some libraries. And look where we start today, in a completely different place. And over the years, we've changed our way of working to capitalize on, one, changing technology trends, and two, the demands of the people who we serve. So agile working's been around a long time. We embrace change. We actively want to collaborate with people. We do things in little pieces so we can learn and adapt. And of course, once we started doing that, what was the big blocker we hit? How long did it take to commission a server or change the network configuration? So all of our change piled up, didn't it? It was really hard to get stuff into production. And then the infrastructure industry responded by saying, well, go on then, we'll make it all code. It's your problem again. You change the infrastructure any way you want. And we found that actually releasing our stuff every sprint was actually quite difficult because we were building quite big bits, large monoliths. They were hard to test and difficult and quite risky to release. So then along came thoughts like, maybe if we had smaller pieces, we could move faster. And that gave us microservices and serverless. And also, the other thing with cloud, we started using reusable services. How many of people use public cloud today? I'm sure you're not just using virtual machines and storage, you're using all of these powerful value-added services. And what's the lovely thing about using one of, say, Amazon's powerful cloud services? Well, they build it for you, don't they? And what's the not so good thing about it? Its problems become your problems, only you don't know anything about it. Who has ever experienced a slowdown on a cloud database that was totally unexpected and afterwards almost totally unexplainable, but it just sort of happened? So that happened to us. And then finally, of course, the people who we hadn't really invited to the party, the operations group, we finally realized that maybe they would be more friendly to us if we told them more about what we were doing and integrated them in. And the DevOps movement started. It was very exciting to bring the two sides together into one team. And SRE has been an interpretation of that. The reason I mention this is that all of this means when I started doing architecture, we did a lot of it up front because we knew a lot up front. We made a lot of decisions up front, partly because we couldn't change them later. And a lot of those assumptions have just gone. So today we have fluid and evolving architecture, which means we might need to rethink how we go about doing architecture work. Because if we've got constant evolution, if things are changing all the time, and that's by design, we don't know very much early in delivery. When we build systems today, it can be quite difficult to predict where they're going to end up. How many of you have worked for small product companies in their early days, where you think you're building a platform to, I don't know, in the case of someone like Cushion, you're trying to give people overcharged bank charges back. Within 2 years you find no one wants to buy that, so you become a subscription management platform based on the same software. We don't know that much, so there's not so much value in upfront architecture. An approach to try and address that problem is called continuous architecture. And the first question everyone asks is, Do we still need architecture? You will not be surprised if you've seen my talks here or anywhere else. My answer is yes. But I do have reasons for it. It's not just because I like it. The key reasons for me are we still need to achieve quality attributes. That's the architect's name for non-functionals. Alex was talking about the importance of making sure we're testing for performance and security and so on. And so how do we achieve quality attributes? One team in a larger team can't do that by themselves. You've had that many times before. One team can't do the security. There are many people care about our system. Some are our friends, some a bit less so. Some of you probably work for quite large organisations, maybe global organisations. I see a few of them are sponsoring here. You've got groups like compliance and risk and disaster recovery and corporate security. To those people, our systems are really just a problem. They're adding yet more complexity into the environment for them. But all of these people have a legitimate interest in what we're doing. So we've got to make sure that we don't ignore them. Otherwise, bad things will happen. So we've got to balance their different needs and try and trade off between them. And all of this involves making complex trade-offs. Yes, we want it to be fast, but we also need it to be usable. We also need to be able to ship it to production very quickly. We also need to be able to use certain technology. All of those things may be in conflict. So all of this is cross-cutting concerns. It's all stuff that if you go to a single team and say, you're the people who will make the system fast, they legitimately will look at you and go, how would we possibly do that? It's everyone's problem. So there are these things that we just can't wish away, and we also can't isolate. They are fundamentally cross-cutting. So that is my justification for this is why architecture is still important. However, if everything is changing all the time, and we know a lot less at the beginning, rather than architecture being a phase, it's going to have to be a flow of decisions right through our project. Some time ago, two colleagues of mine, Murra Erder and Pierre Pura, had the same thought. They had this about 2012, 2013. And they experimented in their large organizations about how to change the way architects thought. And they wrote a book called Continuous Architecture. And this is the original book from 2015. And they identified 6 principles that they found that if they explained these to people, their architecture work got much more effective. One was today entirely obvious. Think about products, not projects. How many of you were in the industry in 2013? How many of you remember how we organized ourselves? Did we do products back in 2013? Not so much, especially in big companies. We tended to be very project-centric. So actually at the time, that was quite difficult for people to grasp. Second one is focus on the qualities of the system. Development teams are very good, if they work with good product owners, at producing high-quality code that implements functions. You can get functions into a system with a good team, not easily, but there is a proven way to do it. However, the quality attributes keep tripping us up. We often think about them late, they're cross-cutting, they have big impact on all the different teams, so somebody needs to be thinking about those right through the life cycle. The third principle is delay the design decisions as long as you can. This is sort of analogous to the agile community's "you're not going to need it" mantra. It's very similar. It's if you don't know very much, that's a bad time to make a decision. Sometimes you have to make a decision with incomplete information, and then we do the best we can. But if you can delay the decision until you get more information, that's clearly a good thing to do, and yet quite alien to how historically we've often done architecture. We'll make all the big decisions early. Actually, maybe we should make them as late as possible. The fourth principle was actually thinking about how we design systems that are friendly to change. This isn't just, let's do microservices. As Venkat pointed out, there's a lot of trade-offs to picking up microservices. But a much more interesting question is, whatever architectural style we're going to use, can we change this system quickly? If the answer is no, what do we need to do at a system level to make it changeable quickly? It's perfectly possible, as Shopify keep proving, to move very fast with a monolith, but only if you do it intentionally. So think about how you do that. And fundamentally, they are pointing there at smaller pieces tend to be quicker to change. So if you've got big pieces, think about how you can compose them out of small ones, or use more small pieces if that's right for you. The fifth principle is really a poke at historical architects who produce a lot of models and then stop. if we can't build something really well, if we can't test it really effectively and quickly, if we can't deploy it quickly and reliably, and if we don't know how we're going to operate it, we're not going to move fast, are we? We might do lots of software development, but unless we can do all of those 4 competencies really well, really repeatedly, very effectively and quickly, we're not going to get fast change. And that's again, it's a team level thing. We're not going to work out deployment on a single team level. And finally, we don't talk much about this because we're software people. We're not very good with people, and we don't know much about organizational design, but we do notice repeatedly, we've known this for a long time, the structure of your software, whether you like it or not, tends to end up mirroring the structure of your people. So I mean, more recently, the Team Topologies book has put much more sophisticated thinking around that. And in fact, that's the book we point at these days. When they wrote this book, there wasn't that book to point at. But remember, if you put your teams in a certain structure, you'll get software in that structure, whether you like it or not. So what does that actually mean then? Those principles are nice, but in terms of what we'd actually do, well, the key thing really is that historically, most architects have thought about producing a design of the system. Maybe they talked about models, maybe they talked about diagrams, maybe they talked about the architecture, but maybe they talked about blueprints, that was another popular phrase, but fundamentally what they're talking about is, here is how all the pieces of the system exist, the responsibilities of each one, and how they all interact in order to deliver our system. What we are arguing quite strongly is that doing this in a fast-moving environment with lots of small pieces is kind of doomed. And I've had that experience personally. It's one of the reasons when I met Murat quite a long time ago, and he was talking about this, I thought, yeah, getting away from trying to keep models up to date with a fast-moving environment where I keep questioning, is all this effort really worth it, was very attractive. So tangibly then, what are we talking about instead of comprehensive models? Because comprehensive models have for a long time been the North Star of software architecture. Well, there's 3 things we think are really important. One is you do need to understand, you do need to communicate what you might call a theory of operation for the system. How does it work? But rather than trying to enumerate all the pieces, it's much more effective to identify and agree and get everyone to understand the architectural style or styles you're going to use in your system. Is this event-driven, or is it fundamentally client-server? Are we going to have a single data repository, or are we going to have distributed data? When we think about the fundamental organization of the system, what we need to communicate to people is what sort of pieces are okay to have in the system, and what sort of pieces do we not want to have? And for those pieces we do want to have, how do they fit together? So, for example, we could talk about having a microservices style, and perhaps we could talk about having a reporting data repository those microservices use. We're not telling people exactly what set of microservices they have, but we are we say we're RPC driven for some very good reason. What we are saying is we don't want 2 monoliths exchanging events. That's not how our system works. So people know the fundamental pieces to think about when they're doing design work. But of course, even when we've decided the style, there are some detailed things we probably want to agree. My 2 favorites are request handling and logging. If you have 8 Scrum teams and you don't agree logging, how many kinds of log messages will you get in your logs? Somewhere more than 8. If you're lucky, you'll get 8. If you're extremely lucky, you might get 6. And if you're unlucky, you'll get an almost unbounded set of log formats, which if you're woken at 3 o'clock in the morning, asked to work out why your microservice system appears to have stalled, is clearly extremely unhelpful. So there are some things that, although we want to empower teams, we want to give them the freedom to make good decisions, we don't want them freestyling every decision. There are some things it's very important to align. And request handling would be another one, is that we normally need to handle requests in a certain way to guarantee certain qualities. So it doesn't mean we tell people, but it does mean that the entire team needs to agree how request handling is going to work. For example, are we going to be idempotent or not? If we are, how do we do that? What do we do when the service is unavailable? All those kind of things. And that's patterns. So ideally, we identify good, robust patterns to solve the common problems everyone's got to solve, and we implement them in reusable libraries. So then, of course, we're taking a little bit of flexibility away. On the other hand, we're probably saving people lots of time, and we've got a consistent implementation we can rely on. Styles and patterns. The second big deliverable is principles. If we're going to ask people to make good decisions, we better give some guidance, generally agreed, as to what good means. And design principles are a really good way of doing this, because principles make it clear what's important to us, what's not important to us, where do our priorities lie, what are we really afraid of doing that we don't want people to do. And those cut down the design space a bit, and they guide people as to what to consider when they're creating their own design decisions. And then finally, people will make decisions. When was the last time you made a design decision? Probably yesterday when you were at work, wasn't it? Does anyone else understand that design decision? Hopefully, everyone else understands it, but maybe not. Just possible that you've got a bit of homework to do tomorrow when you get back to the office to explain it to people. So capturing decisions, particularly the ones that are cross-team decisions, is super, super important. And decisions become a first-class deliverable of software architects in our approach. There's a couple of reasons for that. One, if we're going to make decisions and we're going to involve people in architecture, people had better understand the decisions. So there'd better be a canonical form to represent them in, and they'd better be well communicated. Second thing is, in the future, undoubtedly, we will look at ourselves and say, why on earth did we choose a document database? And we'll all look at each other and go, I don't remember. However, if we have a design decision that says, we chose a document database because we didn't think we had complex queries, and we needed very, very fast retrieval, only based on primary keys, and we needed a lot of scalability, or at least we think we do now, we can go back and go, oh, we're not mad. Actually, we did need a document database. It's just such a shame we didn't need scalability. We actually have got complex keys, and we need lots of queries. If we knew that at the time, we'd have made a different decision. But it's really useful to have that background, particularly when people move. I've moved on and off a lot of big code bases in my life, and one of the things I've often puzzled over is, why was that decision made? Because it might be perfectly valid today, but it looks mad to me. But nobody's written down the reasoning, and the people are long gone. So it's very hard to work with. And what we're trying to get to is an evolving shared design. We are not trying to get an architect, an architecture team, even worse, enterprise architects, God help us, handing designs to other people. We want everyone on the team to feel a sense of ownership and a stake in the architecture. And if we use this kind of structure, then people may want to create more descriptions, and that's all great. If they're useful and they're kept up to date, blah, blah, that's all great. But if we use styles and patterns, principles and decisions, we create an environment in which people can participate because it's clear where the ground rules are. So how do you actually do this? Well, we think there's 5 things that continuous architects, as we grandly call them, do. 1, they provide technical leadership. 2, they focus on quality attributes as an obsession. They drive architectural decisions. Note the word drive. We'll come back to that in a minute. They manage technical debt intentionally. I've got a bit more to say about technical debt than the others. I'll try and keep moving. And they implement feedback loops, which, as I've discovered over the years, is easier said than done, but it's an important part of it. So, providing technical leadership. It's all about leading rather than managing. Most senior technical people, I've spent my whole career in influencing positions. These days I have actually ended up with a group, but when you look at the size of organisation we are, it's a teeny tiny group of very senior people, and none of us have got big reporting hierarchies. So we've all got to lead, inspire people to do the right thing, lead by example rather than tell people what to do. It's that sort of management. The key thing is we've got to lead the resolution of technical concerns. What do you do in your team if you get to a difficult technical decision? You all go, I don't know. Because in a lot of technical teams I'm working with as a consultant, but also I've been in, it tends to just end up in either a deadlock or the person who's really quite loud and a bit overconfident says, we're doing it this way, and everyone goes, oh, I could argue, but really, life's too short. It's not a very good decision, but let's just move on. Sound vaguely familiar? Yeah, we've all been there. There's quite a few of those people around, aren't there? And they seem to be blessed with less technical decision-making ability than others in some cruel twist of nature. So we need to drive good decisions, make sure the quiet voices are heard, make sure we're making decisions based on data, reasoning, we're logical and so on. A classic one being, are we going to incur technical debt? I'll talk a bit more about that in a minute, but we quite often, don't we? We've got this decision. Do we do it sort of quick and dirty now, and we know we've got a problem, or are we going to try and have all those hard conversations to do it properly? We nearly always do the easy thing, don't we? That's what technical leadership is saying. That might be the right thing to do, but can we just think that through before we hard code the customer names? I love that example. We do have a client. Clearly, I can't say any more, just to say they're a client who is a bit like that, only they've done it with countries. Oh dear. Anyway, that's a story for another day. Find me over a beer for that one. The whole point of this is this leadership is driving towards technical excellence. You are the technical conscience of the team, whoever you are, whatever your job title is. The other thing which is a bit tricky is that we often have to explain technical concepts, what I call upwards, but really it's radiating outwards. There are all kinds of people who do not, for example, really understand the trade-off between slamming a load of if statements now and building some elegant kind of pluggable design. They've never written a bit of software in their lives. Or even worse, have you met the ones who've done Python 101? Probably for data science. They've written 100 lines of code in their life and they think they now get it. And they understand all the trade-offs. Our job is to explain to all of those people as to what the actual consequences of decisions are. The key way that we at Endava, actually, I've found it personally, but Endava, we're a big fan of this too, is that the way to do it is create a leadership group. We take away the single point of failure. We want people to collectively own the technical concerns, spreads knowledge across people. People feel empowered, are empowered, because you're asking them to take accountability and responsibility for things. Very good for career growth. Very good for finding out what people's potential is. Gives you multiple perspectives. The old-fashioned architect was one or two if you're in a big team. It's quite lonely. I always like to ask other people. At least let's spread the blame, if nothing else. But get multiple perspectives, because there's often people you can bring into a technical leadership team who perhaps have a totally different technical background. Maybe they're not the smartest engineer. Maybe they don't have all the modern knowledge. Maybe they've got a lot of experience in other technologies. And actually, they have an insight from some previous experience that no one else on the team has. It's extremely useful. Finally, it frees up your time. If you're a technical lead, architect, lead engineer, you're always swamped. A technical leadership team gives you a good mechanism to help free up your time to focus on what's actually important. The second practice is focusing on quality attributes. I'm not going to say that much about that. One, because it's a huge topic, and secondly, because I suspect you know it all. I suspect you've read this many times in architecture material. To recap, they are the cross-cutting concerns that need system-level attention. Security, performance, resilience, availability, you know them all. You've been studying them for years, I'm sure. The more interesting question is, how on earth do you get attention for them? Most teams and product owners, in my experience, are quite focused on features. Who here is a product owner? 1, 2, that's enough. Okay, I can be rude about product owners. There's not enough of you to cause me serious problems. I always just like to check in case it's a room full of product owners. So have any of you worked, now you three are clearly self-selecting and are very different to this. Have any of you ever worked with a product owner who said, right, this sprint, let's just stop and think. We're going to have to look at scalability. Don't worry about the features, we're going to have to look at scalability. Have any of you, apart from these three excellent product owners, has anyone else met a product owner like that in their lives? One, that's actually, it's good that there is one, because that almost proves the rule. You've got excellent product owners, clearly. Because most product owners I've worked with are, whatever, scalability, if you could do that too. Anyway, here's a full backlog of functional change I desperately need. Why do you desperately need it? Because I've told my boss we're going to deliver it. Oh, okay. And of course what they always say is, well, we don't need it this sprint, do we? No. So how about next sprint? Yeah, that'll be fine. We'll do scalability next sprint. What happens next sprint? They've had that conversation with their boss again, haven't they? And it just never comes around. So the question is, how do we integrate this into continuous architecture? What I've repeatedly found is I have had scalability conversations and resilience conversations till I am blue in the face, which is why I've used blue for part of this. I'm sure you'd all picked up the joke. The key thing I've always found is it's quite tough, but you've got to somehow translate them into business concerns. And of course, I'm not a business person, as is, I'm sure, entirely clear to any business person in this room. The key technique is scenarios, quality attribute scenarios. Explain to them a real-world situation where if this quality attribute is not sufficient, bad things will happen. I mean, a simplistic one would be, it's Black Friday, I know it's an American thing, but some big shopping day, close to Christmas. We have not invested in scalability because you wanted lots of features. Your system will turn to molten dust and you won't be able to process any transactions. Do you understand? Now, that's a bit simplistic. Clearly, that would be patronizing. But you get the point. We bring it to life with a structured story. What's the stimulus? What happens? How should the system respond? And that allows us to get a bit of technical attention. Oh, yeah, I can see. Yes, turning the entire system into molten dust would be a bad thing. Let's not do that. And then the two key things our responsibility then is, once we've got the attention, is measure it, so we're not guessing it, and identify clear tactics for mitigation so we can explain to the product owner, or perhaps they're a business sponsor, or perhaps they're a salesperson for a product, yes, we've been through the scenario, I'm glad you understand, here's what I'm responsibly going to do to prove to you where we are today, and then to prove to you how much better things are, and here are the tangible things we're going to do to make this better. Because that's what breeds confidence. It's not just, well, I'll abandon the team for 3 weeks. And these technical people, they'll kind of mess about with tech stuff, and they probably won't fix it anyway, so I won't let them do it. It's in their best interest, really. I'm just looking after them. Whereas here, a bit more structure makes them think, oh, okay, well, actually, I can see why you're spending the time, and I understand it's going to take 3 sprints of half the team. So say, we get attention with scenarios, and then there are always too many. This is sort of obvious, and product owners hopefully will be really good at this, but again, not always, is that prioritization is really key, because we can't do it all at once, can we? In fact, some of the best meaning teams who I've seen get into the most tangles was trying to identify lots of quality attribute problems at once. And I know there are emergencies, but I've repeatedly seen focusing on one for a period, moving the dial, using the measurements, then saying that's just about good enough, and then going to the second one is much, much more effective than having lots of parallel activity where someone's trying to work on resilience and someone's trying to work on scalability, because they probably end up butting heads. Our job is to help people break these huge goals, like make performance better, into stories. Because again, if we go to Scrum teams and say, we've got some security vulnerabilities, could you address them? Well, that's a big thing to ask a Scrum team to just go and do. Or we have to improve our performance by 30% in the next 4 months. Okay, it's the whole system thing. We normally work on this bit. We need a lot of specialist knowledge. I wonder where we start. And of course, some of your engineers are probably very capable of doing this with you or even for you. But the thing that I think gets in the way of fixing it often is the where do I start? And we need to break it down to very manageable stories. The initial stories are about gathering information and making decisions, not about writing code. But break it into stories, the team goes, that's fine, this is now quite manageable, we can see how we'll do it, we can see it's actually 8 steps, not the 3 we were thinking of. Okay, we could get on with this now. Builds confidence. And then the really difficult bit, you've got the stories, they're on the big backlog, which sprint are they going in? Now again, my advice is to go and work for the 3 product owners in the room, because they clearly will do this for you. But in most cases, that's a difficult conversation, which the leadership team or a leader in the leadership team has to go and have and explain the implications, pointing back at the scenario. We aim to improve performance by 18%, arbitrary number, 18% in the next 6 sprints, if you let us do the following 12 stories. And then, you have to sort of hope that logic kicks in and they go, yes, if I don't do that, bad things will happen. The other thing that I found repeatedly is that there are some quality attributes, resilience and BCP are my 2 favorite. Security is arguably another one where Most development teams don't really like handling them. Resilience and BCP are awkward because, one, they're a bit complicated, and two, you're nearly always dealing with, in a big organization, you're dealing with somebody well outside technology. So business continuity, there's normally a totally non-technical business continuity group who, to be fair, have got a very difficult job. They're trying to work out how to make the entire organization resilient. But your resiliency plans for BCP all have to fit into that. If you go and own that, one, you're setting an example. I'm taking it on a hard one. You can do one of the simple ones. Get on with it. But also is that you're using your level of experience, your ability with stakeholders, your ability to prioritize and handle difficult problems, to take some of the really awkward problems away from the team. I found that to be very successful on a number of levels. So our third practice is to drive architectural decisions. It's making, validating, managing and implementing architectural decisions is really key to doing architecture continuously, because it's the flow of decisions we need to make is actually what turns us from being upfront modelers, very smart, doing a great job, working in a specific way, to being in a continuous life cycle. We've got to try and make sure good decisions are made. Sounds obvious, doesn't it? But how many of the decisions in your system are entirely practical, they're well communicated, they're totally logical and data-based, they're very balanced, you thought about the options, there was no personal bias in which one you picked, it definitely wasn't resume-driven development. Perish the thought that we would ever choose a technology for that reason. And it's well argued, so that when people challenge it, doesn't mean that we're defensive, we can simply explain really well why we made the decision. We've also got to make sure that, remember we had architecture principles, and I have a whole other talk on those, so I'm not going to talk much about them, but the whole idea of architecture principles is explain what people should be thinking about when making decisions to make those trade-offs. We've got to make sure the decisions align with those, or if we're making really good decisions that clash with the architecture principles, that's a really powerful architectural feedback loop. Our principles are wrong, or we're making bad decisions. It's one or the other. It's all us. So it's up to us to decide which is which. But I've found that a number of times where I've set principles for quite a large area, and I've found for some teams they're continually violating them. Not in a kind of we don't care kind of a way, simply a this is how it's got to be kind of a way. And that was actually the most useful thing they could have done, because we realized when we kept asking them why, that there were very good reasons that these principles didn't apply to them. And that allowed us to create much more valuable, nuanced principles. We've got to capture, understood, implemented, and curate decisions. How many of you use architectural decision records? Fair number? How many architectural decisions records do you have? 20? 40? 100? 500? 1,000? They kind of grow, don't they? I mean, you turn away for a few minutes. You thought it was a few minutes. It was actually 6 months. But you look back in Git and you go, oh my goodness, don't we have a lot of decisions? And what's the problem with that? Well, how many things can the human brain deal with? Well, it's 7 to 9, isn't it? Which I think is a bit pessimistic for software developers. They're very bright people. But if we have hundreds of architecture decisions and we don't curate them, keep them up to date, get rid of old ones, what's the most confusing thing about documentation? It gets out of date, yeah? You move on to a project, have you had this? Million lines of code, arbitrarily. You go onto the project, fairly senior technical position, you say, where do I start? They say, just read the documents. Brilliant, you say, I'll get started. Where are they? They're on Confluence. Even better, I can go straight to them. Oh, just before you start, they say, don't read the stuff about backups. We've changed all that. Oh, well, fair enough. I won't read the stuff on backups. Actually, there's a bit on web request handling that's a bit confusing because we don't really do it that way anymore. Okay, backups and web request handling. You know how this ends. You go away with a list of 40 things you're not meant to read in the documentation, and you're just not sure what to read or what not to read. Just the same in design decisions. If we don't curate them, they will lose their value. Not overnight, but it's like a sort of decay function. It's quite hard to assess when they lose their value, but boy, do they. I'm actually working with a client right now who've got some of these problems. They've got lots of decisions. Some are pending, quite a lot are pending. They were never quite crystallized. Some look as if they're out of date, but actually have to go and ask 4 dev teams to check. Some of them are absolutely spot on, that's brilliant, but it's a very long list. So actually, if you need to get to something quickly and remind you, it's really quite hard to do. And they're the best intentioned team. I mean, smart people know what they're doing. So the key thing for me is use the technical leadership group to make, validate, communicate, and implement these decisions. In particular, implement. No point making decisions if they're not done, is it? That's why you've got the technical leadership group. They're all the technical leads from the teams. So they understand and buy into the decisions. They help, they made them or help to make them. You need them to then make sure that they're actually driven. Capture them in a way people can get at. I've seen a few teams where there was clearly architects from, should we be polite and say, very experienced, a long history of architecture, who'd sort of put them in SharePoint lists or Word documents or just stuff that the team just didn't use. They've got to be somewhere the team can go straight to them. So ADR's checked into Git, or your source control, works pretty well. I personally think Confluence, if they're structured and they're not one massive long page, can work pretty well. It's got a good, in particular, it's got a good full text search behind it, which is useful. As I say, curation is really important. Then managing technical debt, which I'll do my best to spend some time on. I realise I'm slightly late, sorry. Technical debt's really well established, isn't it? Everyone in this room not only has heard of technical debt, knows what it is. I'm sure you think about it actively. How many of you are really happy with the level of technical debt on your systems? Yes, those are all the liars, because no one's happy about the technical debt on their systems. But it's very context specific. One person's debt is another person's simplest thing possible. For example, you've hard-coded validation in request handlers. You haven't implemented a chain of responsibility pattern with pluggable validators. Is that debt? Or is that a really simple and effective solution for where we are today? Well, none of us can answer that question because we're not on the project. It is really something that requires lots of judgment. But so why do we care about it? It's kind of nebulous and difficult. We could just ignore it. Well, no, we can't. The reason is, when technical debt builds up, it becomes too expensive to make change. It becomes slow to make change. The team ends up being very inefficient despite working very hard. And that is tremendously unfair to hard-working, competent professionals who actually are doing everything they can to make a project successful, and yet the weight of technical debt is causing them to look as if they're either not working very hard or they're not very good. Or it just becomes very risky to update stuff. How many of you have worked on a project where a piece of technology, which is a bit suboptimal, has been left in place a long time? And as time goes on, the reluctance to remove it goes up and up and up. And it's normally a crisis, isn't it? It goes out of support, or it's got vulnerabilities in it, or suddenly we need to do something it just can't do, and it has to be ripped out at great cost and massive risk. So it's all these things that the architecture team needs to be thinking about. We get technical debt from the environment. Things change all the time. Venkat was reminding us, the only constant is change, in other words. Changing context. This isn't anyone's fault, but it produces lots of technical and functional and usability and lots of debt. Sometimes we don't do the best job we should with development practices. I think that's the most obvious thing people think of with technical debt, but actually things just change. We're sometimes not in the ideal environment. We haven't got enough money. We might be very intentional about technical debt, but it just happens to us. And sometimes our team structures don't help us. We've perhaps got the wrong teams really doing the job. We've got people, this used to be a very common problem when people ran projects. You used to build project teams, they used to learn the domain, then they all used to sort of get put back in the people pool and then put onto other teams, so they went, oh, well, I'm an expert on pricing interest rate swaps. And people would say, well, that's nice. Bit of a shame this is a commercial payments project. And they just have to start again. And it was terrible waste, really, of manpower. But sometimes it happens. You know, people have to move around for whatever reason. And sometimes it's just, lack of communication. The other thing that I see builds technical debt really fast. Have you got any systems that don't have a standing team around them? I'll be honest and say I've had this more times than I care to admit, where it's quite an old system. It's honestly not that important, but actually you can't switch it off because it is doing something quite important. Maybe it's regulatory, but not in the main business flow. So you don't have anyone looking after it the whole time. So what happens when you need to change it or fix a bug? Somebody goes, I really don't want to do this. I'm probably never going to touch it again. I'm going to do the quickest thing possible. And of course, their manager says, well done, because I'd like you back on the main thing as quickly as possible. So we kind of, we just do it to ourselves. The ways we can deal with technical debt, this isn't rocket science, but not that many teams I talk to do this very intentionally. We can do it just in time. We can say, well, technical debt happens, it builds up, And when it gets to a point where it's actually causing us pain, we will pay it back. We will address those kind of technical problems. We can do it little and often. We can say, yes, it builds up, but there's thresholds where we really don't want it to build up to any noticeable level. We never want to be going back to our stakeholders going, we could do, but technical debt first. We always want to keep it under control, so that needs a constant kind of focus on it. Or we can do the kind of cleanup. This is like just in time, only it's a crisis. I've been on this a couple of times in my career where the team has effectively got a velocity of 0. They might be a bit insulted for you to say that, but in reality, they're not very much above 0. Changing stuff is hard. All the tests are flickering. No one's quite sure why we're using some outdated open source libraries that are now a total liability, and everyone's just hating working on the project. So we can do cleanup, but one, it's a difficult conversation. It's typically we're not going to do any functional change for n months. And even then, you often don't know what n is, do you? Because this is the whole point. You've got into a difficult situation. So those are the 3 ways we could do it. I'm not suggesting any one is right or wrong. It's contextual. Clearly, in an ideal world, we all do little and often. Pay it back all the time, like our credit cards. Never let it build up. Everything's good. In reality, if you're in a startup running out of money, I think you'll probably do cleanup. Because you don't know if this code line is going to have any value in 2 years' time, because you've only got, whatever it is, a 22-month runway. And you figure out, if we get enough revenue in the next 2 years, we'll get enough investment, we're just going to rebuild it anyway. That might be an absolutely rational thing to do. And just in time, I've seen teams do that reasonably effectively. They effectively have a deal with their stakeholders, the business, typically, the business, whoever they are, which is, we do build up technical debt because we know velocity is important to you, but every 6 months, we're going to stop for 2 sprints, or whatever it is. Maybe that's a bit long, but every 6 months, we're going to identify a big chunk of effort to try and get it down to acceptable levels. And the only way I've ever seen it, honestly, be sustainable is, we have features, we have the stuff that we need to do for the architecture, and we have our known technical debt. We prioritize them all, we get them in a unified backlog, and we prioritize across all 3. We don't say, this is a hardening sprint, or we don't say, we always do features first, or we don't say, oh, let's do the architecture stuff, because they always complain otherwise. We need to work with the product owner and explain to them the importance of each one so that we're doing them in the right order. The other way sometimes people do this, because technical debt's hard to explain, some of you may do this today, you agree with the product owners, 15% of our time, or whatever it is, every sprint is going to be spent on, it's normally called technical improvement, but it typically means technical debt repayment. And my final practice is implement feedback loops. Easier said than done. So our normal, we have an architecture cycle going on, we've got architecture decisions and knowledge being created by lots of people, teams using that to create code, flowing down the delivery pipeline, but with rigorous validation and everything going to production with no problems whatsoever. Or is it? It's quite hard to know, isn't it, unless we've got feedback loops. And the reason we need feedback loops is we need to know how well we're doing technically as a team. There's 2 sorts of things that we need to measure. There's artifact measurements and there's operational measurements, and we need to sort of unify the 2. We often look at the 2, but in totally different contexts. The artifact measurements are the stuff we take out of the pipeline. We're measuring what we're producing. Typical things, like security, static violations, code complexity, test failures, all those things. Operational measurements are how much money is flowing through the system, what was the peak load, how many out-of-memory exceptions have we had, whatever's important to us. There's lots of things we can measure. And typically we're over here measuring in, Prometheus, kind of land, taking probes on stuff, lots and lots of hardware stuff measured here. Why do we measure lots and lots of infrastructure stuff here? Because it's really easy. Because most of those tools measure infrastructure stuff really, really well. When we try and measure things inside our application, it's considerably more awkward. Feedback loops are your reality check. They can be automated, semi-automated, or manual. There's actually no reason that a manual feedback loop is a bad thing. If it's not something you measure very often, it needs a lot of judgment, maybe that's the right thing. You extract some data and you look at it. They typically measure quality attributes, though some of them will be business measures, some will be functional structure. And it's important that we look at internal and external ones. It's easy to focus on things that we care about very much. We've got to remember that it's everyone else we're actually serving. Key piece of advice is starting small and simple. It's very easy to attempt to be ambitious, no problem having a vision, but start with a very complicated measurement infrastructure when we haven't measured anything valuable yet. And we've really got to avoid that. Or the other one, which is creeping complexity. We start off with some tactical measurement here and there, and it's all working fine. But then by the time we've got 50 or 60 measures for different things, we've got a right old mess. We've got a few bash scripts running here. We've got some Excel exports coming out of a database here. We've got a Prometheus server that's measuring only the hardware. We've got some application measures which are sort of being collected some other way. It's very easy for it to become a bit of a mess. You end up with a dashboard, for example, where no one's quite sure now what any of the measures mean. They know there are graphs, and they know they're going in different directions, but actually how that value is derived has sort of got lost along the way. So those are the two extremes. You don't want a gold-plated infrastructure that's more complicated than the system. On the other hand, no problem starting small, but you've got to measure the complexity of that intentionally. So, to conclude, the world has changed, which has been great. The world is a much better place than it was with monolithic Xeon Unix, I can assure you. I was there. The two factors, cloud is a metaphor for modern, flexible, code-driven technology, all those things that make us more effective than we used to be, including better programming languages and so on. And our ways of working have changed to be much more responsive, to be thinking about doing streams of little things, incremental and iterative delivery of value, so we can get feedback early. And these allow us to build digital platform-type systems where we don't really know what the end state is. We know that it's broadly in this part of the business, but what the business will pivot to be and what they will want from our platform is not really known, and yet we can deal with that. The way we can deal with that is that we have ended up with continuous software engineering. We may not have done that totally intentionally, but that's where we are today. We are in a very continuous software engineering world. This means there's a lot less value in what you would call upfront architecture, doing lots and lots of very detailed thinking, very prescriptive design up front. So our solution to that is called continuous architecture. There's another talk on why it's a good thing and a bit more philosophical, but 5 things I think it's important to do if you're going to work continuously and do architecture work. Don't care what your job title is. Everyone should be doing architecture work. Providing technical leadership, focusing on the quality attributes, they're not going away and they require a lot of attention right through the life cycle. Intentionally manage technical debt. If you don't, as lead engineers, architects, technical advisors, consultants, whatever you are, if you don't, who else is going to? And if you don't, what's going to happen? The system at some point won't be worth investing in anymore, and it will need to be written off. So if someone's got to do it, it's you. Congratulations. You can thank me later. Manage decisions as first-class architectural artifacts, not as things that we figure out on a conference call, everyone sort of agrees and we move on. They're actually valuable artifacts in themselves. And implement feedback loops. I'm rather trivializing the feedback loops thing. When I've come to look at what teams do and think about this, I've realized it's quite hard to do good feedback loops. And actually, at a previous architecture conference a few weeks ago, I actually gave my first talk on creating feedback loops. It's very much emerging ideas, but if you're really good at creating feedback loops, I'd love to talk to you in the break, because I think they're really difficult to do. To learn more, there are various books in the field. Very, very quickly, Continuous Architecture is the sort of philosophical book. Continuous Architecture is the how-to. And 2 people, George Fairbanks, who's a very senior guy at Google, was independent when he wrote the book, a guy called Michael Keeling, who some of you may have come across, quite well known in architecture. They've written 2 books which are not about continuous architecture, and yet they're philosophically completely aligned with it. They're about how you bring architecture work to teams related to the code and don't try and do it all up front. And finally, we said, remember, teams, structure, software structure, we don't know what to do after that. But however, there are some people who do, and they're the team topologies team. And we know them reasonably well, and we don't know of a better way of thinking about how you structure teams. There's some further reading. On the slides were little tiny thumbnails of books. Those are those other books. I won't go through them now, and I'll just say thank you very much. I'm just out of time, so thank you for your attention.